First we see deleting the first node. Deleting the first node means we are going to delete this particular node. So what we have to do, if I want to delete this node, I simply replace this link like this. It is enough. I just, instead of this start is pointing to this 56, if it once points to 22, and then I can free this memory. In all the deletions we have to check whether it is underflow or not condition. In insertion we are checking the overflow condition. In deletion we have to check the underflow. What it means, for example, if you take this bucket, if I want to insert anything, first we have to check whether it is overflow or not. If I want to insert, there should be some space, then only I can insert anything. If it is overflow, I cannot insert. So that's why in insertion we have to always check. In insertion we have to always check the overflow condition. For in case of delete, we have to check, if I want to delete something from this place, at least one element should be there. If there is no element in this place, how I can delete an element? So for deletion we have to check underflow condition. Underflow means there is nothing in this bucket. So insertion, overflow condition, deletion, underflow condition is must. If I want to delete this first node, instead of connecting start node, instead of connecting to this 56, if it is connected to this 22, automatically our purpose will be over. So first 3 lines, that if statement is for checking the underflow condition. Now we have to use the variable called pointer, which is pointing to the first node. Why we are using this pointer variable? After this link is established, this memory should be free. If I want to remove this memory or reallocate the memory, I need name of this node. So for that, initially I just put it as ptr. Now what we are going to do, now hereafter this is going to be act as a start. Start initially 1000 irukku. The 1000 and I have to replace it into 2000 replace pannanum. The 2000 value where it is available, it is already available in start oda next la idu irukudhu. Appa start la ipo enna store pannum, start is equal to start oda next appdin solittu enna irthum, start oda next is 2000. Now this will be stored it into start, which means that start consisting of address 2000, which is nothing but it is connecting to this particular node. The meaning is like this. So this is the only step. Start is equal to start or next. This connection is established. Now we can free this memory. How I can free this memory? In dynamic memory allocation, there is a function called free additional function. Free pointer, because pointer is the name of this node. Free pointer is removing. So in every deletion, first node or last node or middle node, first 3 lines, if start is equal to null, then write underflow, end of if. This statement is compulsory for checking the underflow condition. And the last but one, that is before this exit statement, you have to write free of pointer. This is compulsory. These two, this is very essential, because then only the memory is getting released. Because that is one of the biggest advantage of dynamic memory allocation. Whereas in array, we cannot release the memory, but here we can release the memory. This memory can be utilized later. Now let me see the deletion of last node. How we can delete the last node. So now we are going to delete this particular node. That is, this is the last node of the list. We are going to delete this. The 3 statements represents the underflow. Now I want to delete this node, means what I am going to do? We have to identify this node and we just name it as pointer, and the previous node, which is name it as pre-pointer. After we are doing this process, we just release this memory, and then pre-pointer or next one we make it as null. Pannitamna it automatically released null. Initially this node is be act as a pointer. Pointer is equal to start. Now we are checking pointer or next one null on check pandrom. It is not null. Now what we are going to do? Pre-pointer is equal to pointer. Pre-pointer is equal to pointer means this will be act as a pre-pointer. Next, pointer is equal to pointer or next. Pointer is equal to pointer or next is. So pointer is equal to pointer or next na. Hereafter this will be a pointer. Then once again the loop. Now we have to check pointer next null on check பண்றோம். It is not equal to null. Once again the condition is true. Pre-pointer is equal to pointer. Pre-pointer is equal to pointer na pre-pointer is equal to இது pointer. But hereafter this will be act as a pre-pointer. Pre-pointer is equal to pointer means this will be act as a pre-pointer. Next pointer is equal to pointer next. Pointer is equal to pointer next is. So pointer is equal to pointer next na hereafter this will be act as a pointer. Now once again it is checking the looping condition. Pointer next not equal to null. Pointer next on the equal to null. The condition is false. Now it is come out. Now our target is achieved. We find out this variable is pointer. This node is pre-pointer. Now our work is very simple. What we have to do? Pre-pointer next one it is initially it is 3000. Now we have to make it as null because இது null ஆக்கணும்னா தான் this is end of the list. So pre-pointer ஓட next field நான் என்னன்னு செட் பண்ணனும் already 3000 இருக்குது அதை நான் reset into null அப்படினு செட் பண்ணிட்டா this will become null. So end of the list. But இந்த memory இன்னும் allocate ஆனது அப்படியே இருக்கும். இதை free பண்றதுக்கு நம்ம என்ன பண்றோம்? Once again free ptr released. Now this is my new linked list. This is the way how to delete the last node of the list. Similar to that of insertion, in deletion also there are two varieties are there, after num or before num. That is, if whether I want to delete a node after the value num or before the value num. You imagine 26 is num. After num means after this 26 the node, this node should be deleted. Before num, that is, if I want to delete before this value, I have to delete this 56. This is after num, this is before num cases. Here we are going to discuss about this after num case. Particular node is going to be deleted. That is 95. First we have to check the underflow condition. The first three statements represent the underflow condition. Initially this is going to be pointer. This variable is pre-pointer also. By the statement pointer is equal to start and pre-pointer is equal to pointer, it means that this node is going to be pointer as well as pre-pointer. Now there is a while condition. Pre-pointer oda data வந்து num அப்படினு செக் பண்றோம். இப்போ num ல என்ன இருக்குது நம்ம சொன்னோம்? num is equal to 26. Pre-pointer oda data whether it is not equal to check பண்ண சொல்லிருக்காங்க. So pre-pointer oda data not equal to this one. The condition is true. Now pre-pointer is equal to pointer. So there is no change in pre-pointer because already pre-pointer is pointer ரெண்டு ஒரே லொகேஷன்ல தான் பாயிண்ட் பண்ணிட்டு இருக்கு. Pointer is equal to pointer next. Now this will become pointer. Once again check the condition. Pre-pointer data not equal to num. Pre-pointer data not equal to num. The condition is true. Now pre-pointer is equal to pointer na. இப்போ இதுதான் pointer. Pre-pointer is equal to pointer means hereafter this is pre-pointer. Next again pointer is equal to pointer next. Now the pointer is equal to pointer next. Now we once again check the condition. Pre-pointer data not equal to num. Pre-pointer data not equal to num. The condition is false. It is come out of the loop. Now we find out this is the name of this node is pre-pointer. The name of this node is pointer. Now what we are going to do? We are going to delete this node because after this 26 node தான் delete பண்ண சொல்லிருக்கோம். So இப்போ இத தான் நான் delete பண்ணனும். இப்போ இத delete பண்ணனும்னா how I can delete this? இந்த node எங்க இருக்கு? After 26 before 11 இருக்குது. இப்போ நான் இத delete பண்ணனும். இத நான் delete பண்ணா என்ன பண்ணலாம்? 26 95 பாயிண்ட் பண்ணி 26ங்கிறது 95 பாயிண்ட் பண்ணிட்டு இருக்குது. 95ங்கிறது 11 பாயிண்ட் பண்ணிட்டு இருக்கு. இப்போ நான் இத delete பண்ணா என்ன ஆகும்? The 26 அப்படிங்கிறது 11 பாயிண்ட் பண்ணா போதும். The 26 ஓட லிங்க் தூக்கி 11 பாயிண்ட் பண்ண சொல்லிட்டீங்கன்னா automatically this is disconnected. இதை நான் ஃப்ரீ பண்ணிக்கலாம். ஸோ அதை தான் நம்ம இங்கே என்ன பண்ணுறோம். ஸோ இப்போ என்ன பண்ண போகிறோம்? இந்த 26ஐ எடுத்து connected to this one இதை பண்ணணும். இது எப்படி பண்ணுறது? இப்போ நமக்கு இதுக்கு பேர் தெரியும், இதனோட பேர் தெரியும், இதனோட பேர் நமக்கு இப்போதைக்கு தெரியாது. பட் இது இன்டைரக்டாக இது நமக்கு தெரியும். இன்டைரக்டாக இது என்னது? பாயிண்டரோட நெக்ஸ்ட்டு தான் இது. அப்போ இன்டைரக்டாக இதனோட பேர் என்ன, பாயிண்டரோட நெக்ஸ்ட்னு சொல்லலாமா. how I can write the statement, ப்ரீ பாயிண்டரோட நெக்ஸ்ட், ஆல்ரெடி ப்ரீ பாயிண்டரோட நெக்ஸ்ட் இது இதை பாயிண்ட் பண்ணிட்டு இருக்குது, அதுக்கு பதிலாக ப்ரீ பாயிண்டரோட நெக்ஸ்ட் ஈக்குவல் டு, இந்த நெக்ஸ்ட்டை நான் எங்கே கொண்டு போகிறேன், கொண்டு போய் இங்கே வைக்கணும். இப்போ இந்த நோடுக்கு என்ன பேர் நம்ம சொல்லியிருக்கோம், பாயிண்டரோட நெக்ஸ்ட்னு சொல்லியிருக்கோம். ஸோ பாயிண்டரோட நெக்ஸ்ட் உங்கள் அல்காரிதத்தை பார்த்தா தெரியும், ப்ரீ பாயிண்டரோட நெக்ஸ்ட் இஸ் ஈக்குவல் டு பாயிண்டரோட நெக்ஸ்ட். அப்போ ஆட்டோமேட்டிக்லி திஸ் கனெக்ஷன் வில் பி எஸ்டாப்ளிஷ். இப்போ நான் என்ன பண்ணணும், இந்த மெமரியை ரிலீஸ் பண்ணணும். இந்த மெமரி ரிலீஸ் பண்ணால் இதுக்கு ஒரு பேர் வேணும், ஆல்ரெடி இதனோட நேம் தான் பாயிண்டர். அப்போ ஐ ஜஸ்ட் ரைட் த ஸ்டேட்மெண்ட் ஃப்ரீ ptr. எல்லா டெலிஷன்லையுமே வந்து ஃபஸ்ட்டு 3 ஸ்டேட்மெண்ட் செக்கிங் தி அண்டர்ஃப்ளோ கண்டிஷன் இஸ் காமன். லாஸ்ட் ஸ்டேட்மெண்ட் எக்ஸிட், லாஸ்ட் பட் ஒன் ஸ்டேட்மெண்ட் இஸ் ஃப்ரீ ஆஃப் பாயிண்டர்.